July 25, 2000. Charles de Gaulle Airport, Paris, 2:42 p.m. local time. The most beautiful aircraft ever built is accelerating down runway 26 right. Inside the cockpit, 3 of the most experienced Concorde pilots in the world are watching their speed indicators climb. 100 knots, 150 knots, V1. There's no going back now. 178 knots. And suddenly, something changes. A noise. Different from the roar of 4 Olympus engines at full afterburner. The captain feels the aircraft pulling hard to the left. He's fighting the rudder. The first officer sees 2 engine lights go dark, and outside, trailing behind this supersonic legend, is a wall of flame 200 feet long. The captain has exactly 121 seconds before his aircraft becomes a fireball. How does the safest aircraft in aviation history, 30 years without a single fatal accident, suddenly become an inferno at 200 knots? What mistake, buried in a maintenance hangar, set this tragedy in motion? And when everything goes wrong at the worst possible moment, can even the most skilled pilots in the world save 109 souls? This is the story of warning signs ignored for 3 decades. Stay with me. I'm Captain Peter Mercer. I've been flying for 25 years, and I've spent a lot of that time studying what happens when things go catastrophically wrong in the cockpit. What you're about to hear is the technical story of Air France Flight 4590, but told from a pilot's point of view, second by second, decision by decision. Welcome aboard, my friend. Let me set the scene for you. It's the afternoon of July 25, 2000 at Charles de Gaulle Airport, one of Europe's busiest hubs, handling over 48 million passengers a year. The weather's pretty good. Clear skies, light winds, visibility unlimited. Nothing that would make any pilot nervous. This is supposed to be a routine flight. Air France Flight 4590 is scheduled to fly from Paris to New York's JFK International Airport. But this isn't just any flight, my friend. The passengers, 100 of them, mostly German tourists, are booked on a once-in-a-lifetime trip. After landing in New York, they're supposed to board a cruise ship bound for Ecuador. This is the vacation they've been planning for years. The aircraft? The legendary Aerospatiale Basse Concorde. Registration FBTSC. If you don't know about the Concorde, let me tell you, this thing is a masterpiece. It first flew on March 2, 1969, and for more than 30 years, it had a spotless safety record. 0 fatal accidents. It could cruise at Mach 2, twice the speed of sound, crossing the Atlantic in under 4 hours. Beautiful delta wing, sleek nose that drooped for landing, 4 Olympus turbojet engines with full afterburner. An engineering marvel. But here's the thing, that delta wing, as gorgeous as it is, comes with a price. To generate enough lift at low speeds, during takeoff and landing, the Concorde needs both high speed and a steep angle of attack. A Boeing 737 rotates around 140 to 150 knots. The Concorde, 200 knots. That puts enormous stress on the tires. In fact, during its 30-year career, the Concorde had suffered 57 tire bursts. 12 of those caused structural damage, 6 punctured fuel tanks. The worst incident was back in 1979, when a Concorde taking off from Washington had a tire burst that penetrated a wing tank, caused a fuel leak, and damaged the hydraulic system so badly the gear wouldn't retract. After that, there was a big investigation. Recommendations were made. Tires were strengthened. Hydraulic protection was improved. But, and this is important, investigators decided the risk of fire from a fuel leak was acceptably low. You'll see in a sec why that was a fatal miscalculation. Now, the crew. These aren't rookies, my friend. This is an elite group. Captain Christian Marty, 54 years old. Total flight time, 13,477 hours. With 317 hours on the Concorde. He's the pilot flying today. First Officer Jean-Marco, 50 years old. Total time, 10 to 35 hours, with 2,098 hours on the Concorde. He's also a simulator instructor on the type. Very experienced, very sharp. Flight engineer Gilles Jardineau, 58 years old. 12,532 total hours. 937 on Concorde. This is about as experienced as you can get. Air France's Concorde crews were a tight-knit group, only about 30 pilots total. These guys knew this aircraft inside and out. But that morning, there were problems. Originally, a different Concorde was supposed to fly this route, but it was swapped out overnight. When the dispatcher started doing the flight planning, he discovered a technical issue. One of the thrust reversers wasn't working. Not a showstopper, you can still fly, but it comes with a performance penalty. It might mean a fuel stop en route. On top of that, there were issues with the passenger manifest. Most of the passengers had flown in from Germany earlier that day, and there'd been some kind of system glitch. Bags weren't matching the manifest, passengers weren't properly checked in. The dispatcher brought this to the flight crew, and the captain said, "We'll handle it from here." They contacted Air France Engineering, asked if the thrust reverser could be fixed, got a yes, kept moving forward. Eventually, they thought they'd sorted out the manifest discrepancy, but when they loaded the aircraft, they ended up with the 19 extra bags that weren't accounted for. More weight than planned. Around 2 p.m. UTC, that's 4 p.m. local time in Paris, the crew started their pre-flight checks. The captain was going to be pilot flying, the first officer, pilot monitoring, the flight engineer managing the systems. When the engineer came back up to the cockpit, he had good news. The thrust reverser was fixed. That meant they could load enough fuel to fly direct to New York. No fuel stop needed. They settled on 95 tons of fuel. That brought the aircraft right up to its maximum structural takeoff weight. When they calculated their speeds, they got V1, decision speed, 150 knots, VR, rotation speed, 198 knots, V2, engine outclimb speed, 220 knots. The dispatcher came in with the final figures. He told the crew he'd calculated 2 tons of taxi fuel. That's going to be important in a minute. All right, my friend, here's where things start moving fast. Let me walk you through this step by step. 2:25 p.m. UTC. Everything's ready. Cabin secure. Passengers seated. The crew gets their startup clearance. They fire up the engines in sequence, 3, 2, then 4 and 1. Once that's done, they ask for taxi clearance. The runway in use today is runway 26, right, one of the longest at Charles de Gaulle. Air traffic control asks the Concorde if they can take an intersection departure to save time, but given their heavy weight, the captain requests the full length of the runway. Smart move. They get taxi clearance and start rolling toward the holding point. 2:35 p.m. UTC. The aircraft is taxiing out. As they're moving, the first officer notices something odd. One of the electrical control systems for the rudder keeps jumping from primary to backup. He mentions it to the flight engineer. Flight engineer. Yeah, that's true. They talk it over, decide to stay in the primary system. The flight engineer says if it keeps happening during takeoff, they'll just ignore it. It's a dispatchable fault, not a safety issue. Meanwhile, about 4 minutes before departure, they start a fuel transfer from the rear trim tank, tank 11, forward to the feeder tanks. This shifts the center of gravity to 54%, which is the sweet spot for a maximum weight takeoff. Transfer completes without issue. Now here's where things get interesting. At almost the exact same time, a Continental Airlines DC-10 HAR is lining up on the same runway, runway 26 right, and taking off. During that takeoff roll, a metal strip, about 43 centimeters long, falls off the DC-10's right engine. The crew has no idea. No warnings, no indications. They just keep flying. Because this happens only a few minutes before the Concorde's departure, there's no time for a runway inspection. In France at that time, runways were only inspected twice a day, so that metal strip is just sitting there on the runway, waiting. 2:42 p.m. UTC. The Concorde reaches the holding point. The captain does a takeoff briefing. Listen to this. Captain, takeoff at maximum weight 185 tons, 4 reheats, max N2 of 103%, failure N2 of 98%. Between 0 and 100 knots, I stop for any oral warning and the tire flash. Between 100 knots and V1, I ignore the gong. I stop for engine fire, tire flash and failure call-out. After V1, we continue on the standard departure and land back on runway 26 right. This is textbook. In the Concorde, a tire flash is a warning light that comes on if there's a sudden pressure loss in a tire. It's serious enough that they'll reject the takeoff for it, even in the high-speed regime, because tire failures on the Concorde have caused problems before. Above V1, they're committed no matter what. The captain also asks the flight engineer, how much fuel they've used during taxi. Remember, the dispatcher calculated 2 tons. The engineer responds, "We've got 800 kilos. Wait, that means they only used about 1 ton of taxi fuel, not 2. Which means they're now roughly 800 kilograms over maximum takeoff weight. The flight engineer also reports brake temperatures checked at 150. Captain, hotter on the left or right? Engineer, about the same. That's going to be important later. 2:42 p.m. UTC. The Concorde is cleared to line up and take off, runway 26 right. Air traffic control gives them the winds, 90 degrees at 8 knots. Hang on, that's a tailwind. The pilots hadn't calculated for that much tailwind. If they had, they would have seen that their max takeoff weight was now reduced to 180 tons, not 185. The limiting factor, tire speed. With a tailwind, you reach a higher ground speed before you get enough airspeed to rotate. The tires can't handle it. The investigation would later say this didn't directly cause the accident, and I get it. When you're lining up, a lot's happening at once. If you suddenly get different winds than you planned for, it's easy to miss. But listen, my friend, if you're a pilot, you gotta take that extra second to think about the wind before you advance those thrust levers. It matters. All right. From this point on, things happen fast. This is where the 121 seconds start begin. 0.42 to 30 p.m. UTC. The captain advances the 4 thrust levers to take off thrust. All 4 Olympus engines roar to life with full afterburner engaged. The Concorde starts accelerating down the runway. 24 seconds later, first officer, 100, flight engineer, 4 greens. That means all 4 engines are working normally and all 4 afterburners are lit. Everything looks good. 6 seconds later, first officer, V1. There's no going back now. This is about 35 seconds into the flight. 2:43:09 p.m. UTC. The flight data recorder shows a slight yaw to the left, not caused by rudder input. At this point, about 1,700 meters down the runway, investigators later found pieces of the water deflector from the left main gear. The Concorde just rolled over that metal strip. Half a second later, a loud noise is recorded on the cockpit voice recorder. That's the sound of a tire exploding. The left main gear bogie. Investigators found the metal strip and tire debris at this exact spot on the runway. 1 second later, the aircraft is doing WAOS, 178 knots. About 1,110 meters into the takeoff, a different noise is heard in the cockpit. Here's what just happened, my friend. Pieces of that exploded tire were thrown upward at nearly 200 knots and slammed into the underside of the left wing, right where fuel tank number 5 is located. The impact was so violent, it didn't just puncture the tank from the outside. It buckled the metal inward, creating a massive pressure wave inside the tank. And because the tank was completely full, that pressure wave had nowhere to go. It ruptured the tank from the inside out. Investigators found pieces of tank number 5 at this spot on the runway. The metal was bent outward, proving the rupture came from inside. Now several dozen liters of fuel per second are gushing out of that hole, and something ignites it. What caused the ignition? Most likely, when the tire exploded, it severed electrical wires in the left gear strut. Those wires started sparking, and that ignited the fuel. And because the landing gear was still extended, there was a turbulence zone behind it that allowed the flame to stabilize and sustain itself. The airstream couldn't blow it out. The aircraft starts veering left. The captain counters with right rudder to stay on the center line. This isn't because the engines are failing yet. It's because of the damaged tires and the aerodynamic drag from the fire. 2 seconds later, the aircraft is losing thrust on both engine 1 and engine 2. Both engines on the left side. Engine 1 is ingesting debris, rubber, metal, hot gases. Engine 2, which is closest to the landing gear, is ingesting hot gases and choking. The compressor is stalling. The engines are failing. First officer, watch out. Flight engineer, watch out. The 2 go lights for engines 1 and 2 just went dark. The aircraft is now at 187 knots. Still 8 knots below rotation speed, but with both left engines essentially dead, the aircraft is yawing hard to the left. The captain's fighting it, but they're starting to drift off the center line. We don't know exactly why the captain decides to rotate early. Maybe he's worried about running off the runway. Maybe he sees traffic ahead. But he starts pulling back on the stick, slower than normal, probably because he knows the speed isn't quite there yet. As the aircraft rotates, the flight engineer calls out something that sounds like "Moose, stop," but it's not clear on the recording. 1 second later, flight engineer, engine failure, engine number 2. He's calling engine 2 because engine 1 is actually starting to recover from the initial stalls. But as the nose comes up higher and higher, the airflow around the wings changes. Those hot gases are now being sucked into both engines, probably through the secondary air intakes underneath. Both engines stall again. Thrust drops back to near idle, and then the first engine fire alarm sounds in the cockpit. Flight engineer, shut down engine number 2. Captain, engine fire procedure. At the same moment, the air traffic controller in the tower is watching this unfold. He keys his mic. ATC. Air France 4590, you have flames. You have flames trailing behind. The first officer reads it back. The flight engineer is now executing the engine fire procedure. He pulls the thrust lever for engine 2 back to idle. He pulls and rotates the engine fire handle. The fire alarm stops momentarily, the extinguishers cooling the engine, but it comes right back. Because the fire isn't in the engine, it's outside, and it's massive. While this is happening, another aircraft somewhere on the airport keys their mic. Unknown pilot. It's really burning, eh? It's burning, and I'm not sure it's coming from the engine. That radio call is going to be key evidence for the investigators. The Concorde is finally airborne. Just before liftoff, it ran over a few runway edge lights on the left side. Now the crew faces the next problem. Airspeed. Because they rotated early, they're holding 200 knots. But their engine-out climb speed is 220 knots. At 200 knots, with this much weight and drag, they can't climb. They can barely maintain altitude. First officer, speed, speed, speed. Engine 1 is recovering slightly, but it's heavily damaged. It'll never produce full thrust again. Engine 2 is shut down. Engines 3 and 4 have gone into contingency mode, producing as much thrust as they possibly can to compensate. The Concorde is at 100 feet above the ground, climbing at about high 750 feet per minute, doing high 200 knots. ATC, Air France 4590, you have large flames trailing behind you. You have priority to return to the airfield. The first officer reads it back. Flight engineer, gear up. First officer, no. He knows the procedure. If there's gear damage, you don't retract it. Captain, gear up. Direct order. The first officer tries, but the gear won't retract. It's stuck. The explosion probably damaged the left gear door, and because of the retraction sequence, if the door doesn't move, the gear stays out. Captain, are you shutting down engine 2? Flight engineer, yes, it's shut down. First officer, airspeed, speed, the gear is not retracting. 2:43:55 p.m. UTC. The flight data recorder shows an uncommanded roll. The fire has been burning long enough that it's starting to melt the inboard 11 on the left wing. Flight control problems. The captain's fighting it. The nose is pitching up. Angle of attack is increasing. The first officer hears ATC talking to the fire crews, telling them the Concorde will land on the opposite runway. He keys the mic. First officer, Le Bourget, Le Bourget. We're gonna try for Le Bourget. Le Bourget is a smaller airport nearby. Closer. Maybe they can make it. The engine fire alarm sounds again. Engine 1 surges again. All remaining thrust on the left side is gone. The aircraft rolls hard to the left. At the worst point, the bank angle reaches 113 degrees. The aircraft is almost inverted. The ground proximity warning system activates. GPWS. Whoop, whoop, pull up. Pull up. There's indication the thrust levers for engines 3 and 4 are being pulled back, probably trying to stop the roll, get the wings level. It's too late. 40:31 p.m. UTC. Air France flight 4590 crashes into the Hotelissimo in Gonesse, just west of Charles de Gaulle Airport. All-out 109 people. On board are killed instantly. 4 people in the hotel die as well. Total, 113 fatalities. Imagine this for a second, my friend. You're the captain. You've just rotated an aircraft that weighs over 400,000 pounds, and you're holding it in the air by sheer will and whatever thrust you've got left. You've got a fire the size of a school bus trailing behind you. Your left engines are gone. Your gear won't come up, your flight controls are melting, and you're rolling hard toward the ground. You pull back on the stick. Nothing. You push right rudder. The nose won't come around. The first officer is calling out airspeeds. The flight engineer is trying to save whatever systems he can. The ground is rushing up. You've done everything right. You've flown this aircraft for years. You know every switch, every system, every procedure. And it's not enough. The Concorde hits the hotel at over 200 knots. The impact is catastrophic. The fireball is visible for miles. In less than 2 minutes, one of the most beautiful machines ever built has been reduced to burning wreckage. Let me be clear about something. These pilots fought until the very last second. Captain Marty tried everything. He used every bit of rudder authority he had. He managed the thrust on the remaining engines. He kept the nose up as long as he could. But here's the thing. Physics doesn't care how skilled you are. When you've got that much weight, that little thrust, and that much drag from the gear and the fire, the aircraft just can't stay in the air. The first officer was calling out critical information, airspeed, gear status, trying to give the captain every piece of data he needed. The flight engineer was executing procedures, trying to isolate the fire, trying to save what he could. But the fire was eating through the wing structure. The flight controls were failing, and without that gear coming up, the drag was just too much. They fought, they gave it everything, but sometimes, my friend, the aircraft just can't be saved. The crash site was horrific. Emergency crews were on scene within minutes, but there was nothing they could do. The fire was too intense, the wreckage too complete. All 100 passengers, mostly German tourists on the trip of a lifetime, were gone. The 6 cabin crew members, the 3 pilots, and 4 people in the hotel who were just going about their day. 113 lives lost in 121 seconds. The immediate question was, how? How does the safest aircraft in the world just fall out of the sky? All right, my friend, let's break down what the investigators found. Because this accident, it's a cascade of failures, some of which had been building for 30 years. First, the metal strip. That piece of metal that fell off the Continental DC-10. It wasn't supposed to be there. When investigators went to Continental Airlines and pulled the maintenance records, they found that this strip had been replaced twice in the previous 2 months. It kept falling off. And here's the kicker. The metal strip wasn't even manufactured to the engine maker's specifications. It had been drilled 37 times instead of the required 12. The strip next to it was too long, which was causing constant wear. It was only a matter of time before it fell off again. Can you believe this? A part that's been failing repeatedly, installed incorrectly, and nobody thought to ground the aircraft and fix it properly. Second, the tire. When that tire hit the metal strip at 178 knots, it didn't just blow, it exploded. Pieces of rubber weighing several kilograms were launched upward at nearly 200 knots. That's like getting hit by a cannonball. The force of that impact was enough to buckle the fuel tank from the inside. The tank didn't just puncture, it ruptured. Fuel poured out at a rate of dozens of liters per second. Third, the fire. Here's where it gets really bad. When that fuel ignited, probably from electrical arcing in the damaged landing gear strut, the fire became self-sustaining. And because the gear was still down, there was a turbulence zone behind it that kept the flame from being blown out. The fire was so intense it started melting the wing structure. The flight controls failed. The engines on the left side choked on hot gases and debris. Fourth, the gear won't retract. The landing gear door was probably damaged by the tire explosion, and because of the way the Concorde's gear retraction sequence works, if that door doesn't move, the gear stays out, period. With the gear down, the drag was enormous. At 200 knots, with the weight they were carrying, the aircraft just couldn't accelerate. It couldn't climb. It was barely flying. Fifth, 30 years of warnings. And you know what makes this even worse? The Concorde had a history of tire problems. 57 tire bursts over 30 years, 12 caused structural damage, 6 punctured fuel tanks. After the 1979 incident, recommendations were made. Tires were improved. But the fundamental vulnerability, unprotected fuel tanks beneath a high-speed wing was never fully addressed. Investigators in 1979 concluded the risk of fire was acceptably low. They were wrong. Here's what the industry learned, my friend. Immediately after the crash, the Concorde's certificate of airworthiness was suspended, grounded, until serious improvements could be made. The changes included 1. Kevlar lining inside the fuel tanks to prevent ruptures from impact. 2. Burst-resistant tires. New NZG Michelin tires designed to withstand higher forces. 3. Electrical system protection. In the landing gear strut and wheel well to prevent arcing. 4. Improved wiring. To reduce the risk of fire ignition, the Concorde was grounded for over a year. And just as it was about to return to service, 9/11 happened. The aviation industry collapsed. Demand plummeted. The Concorde flew for about 2 more years. On fire. October 24, 2003, British Airways retired the last Concorde. The era of passenger supersonic flight was over. There were also serious legal consequences. The French investigation team pointed to Continental Airlines and the DC-10's faulty metal strip as a contributing cause. Continental fought back, saying the missing spacer in the Concorde's landing gear was to blame. In the end, the courts found both parties partially responsible. But here's my question for you, my friend. How many warnings does it take before we fix a problem? The Concorde had 57 tire bursts, 12 caused damage, 6 punctured tanks, and still, the fundamental design vulnerability wasn't addressed. What do you think? Should they have grounded it sooner, or was this just an unforeseeable chain of events? Aviation is the safest form of transportation in the world, but that safety is built on the lessons of tragedies like this one. Every time an aircraft goes down, investigators dig into every detail, every failure, every decision, so that it never happens again. The Concorde was a masterpiece, a symbol of human ambition and engineering brilliance. But it was also a reminder that even the most beautiful machines are still subject to the laws of physics and the consequences of overlooked warnings. If you found today's episode valuable, my friend, I'd appreciate it if you'd hit that like button and subscribe. I've got more stories like this one, stories about crews who faced the impossible and fought till the very end. This is Captain Peter Mercer. Thanks for being my co-pilot today. See you on the next flight.